Hello, good evening, and welcome to another lecture of design of concrete structures. This is our second lecture on prestressed concrete. Yesterday, we have discussed the introduction about the prestressed concrete, and we have seen what is the prestressed concrete, what are the advantages, and where we are going to use, or what are the applications of prestressed concrete. Now, and we have seen the different methods of pre-stressed concrete, means pre-tensioning and post-tensioning, right? Now we will see in this lecture, we'll go to the analysis part of the pre-stressed concrete, okay, and we'll try to do a numerical problem also. So coming to the analysis part, before I enter into analysis, see, we are mainly, because when I say pre-stressed concrete, we play with the stress actually. So our stress is important. So our idea is to find out the stresses in the top fiber and the bottom fiber. That is what the idea of when I say an analysis actually. Okay. So there are two stages are there in stress calculation. One is called transfer stage, other one is called service stage. When I say transfer stage, the meaning is that just before the loading. For example, you have done your formwork and everything. Right now you did casting and everything. So at that time it is before the loading only, because live load is yet to act on it. So that stage is called the transfer stage. Then once the what I say, the live load came into picture, then that's called the service stage, because when it started using it, when it started serving, if the building is means it started serving the humanity for the what purpose it has been cast, it has been constructed. So that's called service stage, means after loading. So that is one thing. I will come back to that. And another thing, the basic thing we should remember is, you must be knowing the equation, like the universal bending equation, m by I is equal to f by y is equal to E by R, right? From that you can get you can derive like m is equal to f into z, where m is the bending moment, f is the stress, and z is the section modulus. So from this equation I can write F is equal to m by z. Stress is equal to bending moment divided by section modulus. So this equation you please keep in mind. Now coming to the stress, I told you already, there is a transfer stage before it is getting loaded. Another thing is a self-weight after loading. So remember, in a pre-stressed concrete, see this figure. In this pre-stressed concrete, what we do is we have this tendons or reinforcement, we call it as a tendons. These tendons, what we do is we will stress it, we will stretch it, we will pull it to the maximum limited with some force. Let us say this force is P0, okay, and we cast it, right? Once the concrete is set, after curing, what we do is we will cut the steel. So this steel will try to come back, but the concrete will not allow it to come back, because concrete is set, and around the steel there is a concrete. So that because of the heavy bond, it will not allow the steel to come back. So automatically what happens, there is a compressive stress, a pushing effect is created, okay, right? So this force you should keep in mind, this P0, it is called a pre-compressive force, okay, or pre-stressing force, the initial pre-stressing force, okay. Then what is happening is, once this setting is over and when it start using, the live load comes, what happens, you will not be having the same force here actually. Why? Because there is a chance of slip. What I mean to say is, you are applying a force initially, let us say 100 kilonewton, but once what I say, it started using, when the live load and all comes, you are supposed to get this 100 kilonewton here also, but you may not get, because it will try to push it down. So what happens is, the steel might come, what I say, there will be having a slip. what's called a loss. So maybe instead of 100 which we applied initially, now that load may be some 80 or 85. Okay, so 100 become 85, so that 15, that is called the loss actually. Understood. So normally if the loss is normally it will be given in the question. If it is not given, you can take it as a 15 percentage. Means if you are using 100, 15 percentage of 100 is 15. That is the loss. So actual will be 0.85. 85 percentage of the P0 will be the final prestressing force. So P0 is the initial prestressing force, and P is the final prestressing force. Okay. If it is 15 percentage means 0.15. So the eta is taken as 1 minus 0.1 losses, means 1 minus 0.15. It is equal to 0.85. Meaning is that the final prestressing force P is equal to eta times mu into P0, initial prestressing force. So this thing you just keep in mind. And coming to the stress transfer and service again, as I told you, it's before loading. So in transfer stage you will be having only two loads actually. One is P0, which is for initial prestressing force, and your dead load, because it is not the live load has not yet come to the picture. And in the service stage you will have final prestressing force. Okay, see the difference. This P0 and now it will become P because of the slip, because of the loss. Okay, in the service it will be P, final prestressing force, and you have your dead load, the weight of the structure, weight of the beam or weight of the slab, whatever it is, and your live load, okay, which is the imposter load. So just please understand this. Now let us this is what I have discussed before: initial prestressing force and final prestressing force. We denote it as a P0, P. The P0 will be always greater than P actually, right? This I discussed already. Now see the situation. Let us say this is a concrete block, and the tenton is placed at a distance eccentricity E from the center of CG, and the initial prestressing force is P0. And once the concrete is cast and attained strength, we are cutting the steel here actually. Let us say we are cutting the steel here. So what will happen? The steel will come back. It will push the concrete. So as I told you, the initial prestressing in the transfer stage you have initial prestressing force P0 and your dead load only. So the first thing what happens is this, because of the P0 it will push it from both sides. So there is a compressive stress developed. What is that actual compressive stress? The stress is nothing but force by area, P0 by area. See the compressive stress developed the full section. The another thing is that this P0 is applied at a distance E from the CG, center of gravity. So it will create a moment actually. So because of this P0 force, there exists a moment. So say think like that, we are applying the P0 at bottom, because once steel is cut, this force it will push it from both sides. So it will try to bend like this. Think of a sponge piece you are taking and pushing it from the bottom. So what happens? It will bend like this. Correct? No? Okay. So if anything is bending, there should be a bending moment. Correct? No? So this bending moment is nothing but P0 into Z. So when it bends like this, top fiber will experience tension, bottom will experience compression. Okay. So your stress diagram will be like this. Top will be P0 M, P moment by Z. You see here, stress is M by Z. M is P0 and E, P0 and E by Z, and P0 and E by Z at bottom also. But since top is a tension, we are taking compression as positive, tension negative. It will be negative, it will be positive. Understood the point? Yeah. And come to this side. So you have this 2 is completed now. Now what happens is your dead load, the weight of the slab itself. So what happens? The weight of the slab is applied on the slab from the top. So it will bend like this. Correct? So top will be compression and bottom will be tension. So the stresses will be moment due to dead load, the MD by Z, and md by moment due to dead load. Okay, md by z and md by z at bottom. So since it is a compression here, top will be positive and bottom will be negative. Got the point? So first stage it is P0 by A, second stage it is P0 E by Z. The top is tension, bottom is compression. So negative and positive, negative at top and bottom, positive at bottom. And another stage, because of dead load, it bends like this down. So top will be compression, which is positive, and bottom will be negative. So your resultant stress, the actual stress in the beam at top fiber will be sigma u. I can write P0 by A positive minus top. I am taking only the top minus P0 E by y minus, it is a negative here because top it is tension, minus P0 E by Z plus MD by Z. And what is stress at respective stress at bottom? It is P0A positive plus P0 E by Z minus MD by Z. How do you calculate MD? MD is bending moment due to dead load. MD means you find out WD, in which is self-weight, WD in L square by 8, which is moment. And how to calculate Z? Z is modulus of section. For a rectangular section, Z is BD square by 6. So your effective diagram will be like this: positive, negative, positive. So this is also positive below. So you will ultimately, what is happening is you are eliminating the negative stress, tension. Now come to this service stage. Service stage means your actual load is applied, your live load is applied. So you have final pre-stressing force plus dead load plus live load. Okay. So first stage, because of the when it started using, because removing the prop and everything is removed, the actual load is applied. So because of this P, final pre-stressing force, this will push both sides. So you will have P by A, which is only in compression everywhere. So positive. Next is because of this moment P0, because tendon is applied at bottom, it is laid in the bottom. So there is an eccentricity. So it will be P into E by Z, moment M by Z, stress is M by Z. So PE by Z and PE by Z. Top it is negative, bottom it is positive. Or top tension, bottom compression. And next is dead load. So MD by Z and MD by Z, same as in the case of before. Top it is compression, bottom is negative. So positive and negative. Then the another load comes is live load. Because of live load you have ML by, because when I say ML, meaning is that bending moment due to live load, ML, which is calculated by WL into L square by 8. WL means live load, WL, superimposed load, into L square by 8. Because in a simply supporter beam, WL square by 8. Consider as a simply supporter beam. ML by Z, because this is also positive. Top compression, bottom tension. So you will get. So your resultant stress at top will be P by A positive, PE by Z minus negative, MD by Z positive, ML by Z positive. So it can be written like this: P by A minus PE by Z plus MD by Z plus ML by Z. And bottom will be P by A, then PE by Z positive, MD by Z negative, ML by Z negative. So remember why this top negative, bottom positive means it is because of how it bends. If it is bending, since it is bending like this, top it is a tension, so it is negative. It is bending like this, so top it is compression, so it is positive. Bottom it is tension, so it is negative. That is how it comes. So your final stress diagram will be either like this or either say slight negative. Depends upon how much is the values of all this. So it will be coming like this. It can be sometimes 0 also at bottom. Okay. So that one, after getting the final value only, you will come to know how does it look like. Okay. So I think this is how this is the final one. All these things. And one thing I would like to indicate is you got it, sigma u is like this, P by A minus P0. This is the final pre-stressing force. So previously I was telling you like there is a possibility of initial pre-stressing force we know, and there is some amount of forces will be lost. Okay, normally it is mu, what is a 15%. So this eta will be 0.85. It is percent, it means 0.15 is lost, so actual will be only 0.85. so your final pre-stressing force will be 0.85 times P0, otherwise eta times P0. so you can write like this, because the final the service stage, your sigma u will, upper stresses will be P by A. So instead of P by A I can write like this, eta into P0 by A, because final pre-stressing force will be eta times initial pre-stressing force. I can write like this, eta into P0 by A minus P into E by Z, final pre-stressing force. I can write like this, eta into initial pre-stressing force into E by Z, like this. So eta I can take common factor and I can write like this, P0 by A minus P0 E by Z plus MD by Z, and same way here also. So that's all with this, and we'll try to do a problem so it will be more clear. Thank you very much.